Welcome to today's session of programming in Python. In the preceding classes, we have learned functions, modules, decision making, and loops, and many other basic concepts. And today's session shall be focusing on classes and object. In the classes and object, it is just a style of programming. Just like you have a concept of function, whose use more efficient and uh, more readable. The same way, even the use of classes and objects. So the broadly, this classes and object is termed under the object-oriented programming, which is also called as OOP. Okay, it is nothing but object-oriented programming. As you can see, as the name suggests, it's a object oriented. So it's kind of a style, or you can say, the approach towards programming is mostly as an object. Now you must be wondering what an object is. Then I would say, uh, correlating with the everyday examples, like a car. So car is kind of a concept, or electrical architecture, or a good engineering, isn't it? However, when it comes to BMW car, or a Jaguar car, or a Land Rover car, or a Maruti Suzuki or Toyota, you take any model of those, you can term them although all of them are a car, but when you consider each of them the individual specific cars, then they could be termed as objects or the instances. Okay, or you can say they are the examples, isn't it? It's a car which you can say a blueprint. Okay, you can say a blueprint, or you can say template. Okay, because if you have the technology or the methodology or the ways to build a car, you can build any kind of car. You can, you all the changes that you have to do, the only thing that is going to differ, whether it's a color of the car, you make a blue car or a red car, or whether you put the engine in the front or the back, or whether the car has the sunroof or it doesn't have a sunroof. All these are configurations, all these are attributes of different cars which could be different, but at the core, all the car are same. They are built using the same technology, or the same blueprint, or you can say same template, right? Exactly. So correlating it with this particular real life example, if I were to tell you what an object in the object oriented programming is, and what a class is an object is, then I would say the car can be termed as a class, and object, and then I can say, say Jaguar F-Pace can be termed as one object. I can say Tata, I can say maybe Tata, Nexon, XMS. Now this is one specific model, isn't it? It can be termed as another object, object 2. Okay, and then I can say maybe um, Land Rover L663. Okay, maybe this can be termed as, oh, I'm sorry, this is not object 24, it is object 2, and this is object 3. All right. The only thing that is differing in this is, of course, these car could be built using this particular technology, this class. However, these are objects. You can say these are individual objects in which what is different? The brand is different. The could be the color, could be the different, could be the model year, could be the different, could be the country in which they are manufactured, it could be different, right? So that's what all the whole the concept of classes and object is. Okay, if I were to make you visualize in a more better way, then what I would do is, let me create a template here. For example, suppose this is a word template, or you can say this is a one form, a form, perhaps a banking form which you need to fill. Okay, this is one empty form which has many fields to be filled, right? This has many fields to be filled. If I give this form to a person A, he is going to fill this up. Okay, so when you fill this up, when you fill this form up, what's going to happen is the name which is filled in this form is going to be different. The parental name is going to be different. The date of birth is going to be different. The address is going to be different. In a similar way, when this same form is filled by another person, it's going to be different form. And the person, third person, again, it's going to be a different form. But this, at the core, all these forms which you see here, how they have the same basic template. They have the same basic template which is here. So you can say that this is class, okay? This is class, and these are objects, okay? You can say this is object 1, this is object 2, and this is object 3. Object, this is object 4, okay? So these are different objects which have the different properties or attributes. The real life example is good so far, but however, let's try to correlate this with now the programming concept. Now let's try to see how do we develop a class in program, how do we develop an object in program, and how do we use it in the programming context, okay? Just like and before I start onto that, let me tell you that in this object oriented programming, uh, before we develop objects, all this while you had been developing the data types, right? You must be developing 5 here, data is 5, or maybe I can say data 2 as list, right? This was also a way to create a list. I'm sure you have learned this way to create a list, but you can also create a list like this. If this is an initializing an empty list, then this is also a way to initialize an empty list. If not list, you can also initialize a empty string like this, and the other way to initialize the empty string is like this, like this. All right. Now you must be wondering, after creating an empty string like this, or after creating a list the other way, how do we have the methods like these, data dot replace? You remember we used to if I were to replace a content in a string, I would use this method. If I have to count any certain characters, I would use this, correct? Let me tell you that in Python, all these data types, they're not data types. Effectively, they are objects, okay? They are objects which are being created by the class str, class string. And when it is when we were creating a list, when we were initializing and creating a list, we are actually creating an object, okay? We are creating an object from a blueprint or from a template, right? If it is not clear to you, or if it is confusing, don't worry. Let's first learn the object oriented programming. Let's first learn how do we create classes, how do we create object, and then it would all make sense to you what I'm talking about. What is this str and what is this list? All right. Okay. Let's first see how do we create a class, and then we are going to see how are we going to create an object from the class. But before we create a class, let me quickly revise how do we create a function. I'm sure you would write a function starting with a keyword def. Def means define, and you would write maybe function name, right? And then followed by colon, and then the body, whatever is contained in a body. Just like this, and just like any other concept in Python, like you would start a while loop like this, and you would put condition and then body. And when it comes to decision making, you would put the keyword if, and then the condition, and then the body, right? In a similar way, when it comes to making dealing with the concepts of classes and object, you write the keyword class, and then you're going to name a class name. For example, let me create a class person, okay? And then I'm going to put a colon, and then I'll put body. See, at the moment, I do not have anything to put. I can, so what I'm going to do, I'm going to put pass. So whether it's a function or decision making, we are ideally supposed to write some of the other content whenever we use this concept. But if I don't have anything to write, if I don't have anything to fill here, I can just write pass, okay? That also work. So if I have to create Now this is like creating a class. Okay, now if I have to create object out of it, I'm going to create maybe Arun. Okay, not Arun, maybe I can say student one equal to person. Okay, and then in a similar context, I'm going to write student 2 as a person. Now the other easy way to understand what a class and object is, then it is wise on our part to to consider that not all the data are simple as 5 or 10 or 15, and not all the data are just limited to some alphabets or numerical data. Some are complex data. For example, person. Who is a person? It's a human, right? A human may have, considering a human itself as a data, it has so many things as a data. It has a hair color, it has the eyes, it has a behavior, it has the skin tone, it has the citizenship, the name, the parental lineage. So many data you can associate, right? How are you going to store the data? It becomes very difficult to store such complex data in a dictionary or a list. Of course, list and dictionary are one way to store the data, but class is another way to hold your data as a it's a different structure which you are going to learn. Okay, so right now this is a way to create a class. Okay, if I run this, it's all going to be fine. Nothing happens here, right? Now what I'm going to write here I'm going to write uh, maybe genome as mammal. Okay, so this is like a template or a blueprint in which I am defining one attribute as genome equals to mammal. That means this is one attribute. This is, you can say, it's a global attribute which gets passed on to every student that is being created. So when I'm saying person and when I'm putting this parenthesis, it looks like a function call, but here person is not a function, person is a class. And here what's happening is it's the initialization of a it's an instantiation of a class. Okay, what is instantiation? It's like an instance is being created, or an example is being created, yeah, or an object is being created. So the the moment you instantiate, Python immediately jumps to this class and it creates one person, and it to that person it associates that the genome is going to be mammal, and that is student 1. When it comes to student 2, another example or another instance of that person is going to be created. Okay, so now here if I print here, say student 1 dot genome, remember this is how we access the attribute. Okay, and if I print this, you are going to see that it says mammal, right? And in a similar way, if I print student 2 dot genome, and if I run this, you will see mammal, right? So they are not same, they are two different individual persons. Student 1 is different, student 2 is different, and they, however, they both are being created by this same architecture or the same template, right? Since this is a common attribute, and that is why both of the students, when you try to access their genome attribute, both of them are printing mammal. I'm pretty sure you must be having a question that what if they have certain attributes which are individual to them, yeah, which are very specific to them. For example, student 1 name could be Michael and student 2 name could be Aliza. Then what happens? How do you give this? How do you store specific data there? To do that, there is a method called as initialization. Okay, within a person, within the class, you are going to write something like def double underscore init, init. Okay, init means initialization, and then followed by another double underscore. Okay, and then here you're going to write self. Okay, why am I writing self here is, see, every time I am creating a student, a individual person is getting created, right? So self means that while some person is being under construction or under development, any attribute which are being defined under this initialization that is very specific to that corresponding student. So if student 1 was under development, then whatever the attribute we are going to define now shortly are applicable to student 1. When it is about student 2, then whatever we are going to define here will be applicable to student 2. Okay. If you're not understanding, then let's see. Okay. Here I'm going to write self dot say name. Okay. Please remember, please memorize, this is the syntax. So this is the way how you have to write. Why? It's because the Python development community or the Python developers have defined the syntax, and here I'm going to, so we have to follow that. So here I'm going to write x or then comma y. Okay, x and y are nothing but they are the, just like in functions you have parameters. So in initialization you're writing two parameters. So when you create a person, for that person's initialization, it is expecting two individual contents. Okay, here I'm write x, here I'll write self dot age. Okay, and I'm going to write y. Fine. Now when I'm calling this particular class, or when I'm instantiating this class, I should give here say Michael. Okay, comma say 30, and here I'm going to give Aliza, comma say 50. Okay. Oh, that's too such a elderly age. Let me give something young 32. Yeah, that's fine. So what's happening here is, for student 1, student 2 genome, I'm printing, then it's printing mammal. But let me print here student 1 comma. So if I'm printing comma and very next to it, if I'm printing, then things get printed side by side. Okay, so I'll write here name, and here I'm going to write, oh, okay, right. If I run this, you will see that it says mammal Michael 30 and mammal Aliza 32. So what happened is, something which you are defining at the global level, that gets passed on to as a common thing or a common attribute to both of them. Okay, both the students. However, anything that I'm writing in this structure in it, okay, what happens is, so when Python comes at this, so what's happening is you're instantiating person, yeah, and you're making a student 1. So when you instantiate person, you are providing two data within parentheses, that is Michael and 30. So what happens is Python comes here and to the student 1, it is going to give this common attribute, that is mammal into genome. And when it comes to initialization, that means it is initializing only student 1. Okay, it is initializing only student 1 with this data. So Michael comes into x and 30 is coming into y, and self dot name is stored as Michael and self dot age is stored as y. And that is why when I'm writing accessing here, so to access a objects attribute, so student 1 is an object, right? Student 2 is an object. So when I'm accessing student 1's name and when I'm accessing student 1's age, it is unique, a unique which was initialized here, right? And in a similar way, when student 2 was being built, Aliza was stored into name and 32 was stored into age, right? So that is why when I'm printing this, I'm getting Michael, a mammal Michael 30 and mammal Aliza 32. Yeah, this is how. So this is how you define a class, and using the class, you can build as many objects as you want. So this was a very basic structure how you create an object using a class. So that is all about it. In the next class, we are going to look further into classes, concepts, and the object concepts, and what all you can do the further concepts like inheritance. Okay, however, this being the basic concepts of creating, defining, and the classes, and how to create object using this class, right?